Now this question is a tad bit tricky, actually on part B. Part A isn't bad at all. So the question is, what is the magnitude of the impulse delivered by the bat to the ball? We've got a mass and we've got a velocity. So the impulse is going to be, no, it's part A, yeah. So it's going to be, you have M1 V1, right? Actually, let's say this. It's M ball, V ball before. So it's moving in this direction. But then when it comes back, you're trying to find the impulse delivered by the ball. You're going to subtract the M final, V final. So when you do the M of the ball, I have 16. It's going at 16 meters per second. Actually, I'll put the first mass. 0.145 times 16 meters per second. But since you're subtracting when he goes back in the other direction, because it's actually plus, if you will, the velocity is negative, right? Because he's moving back in the other direction when the ball comes back the other direction. So it's going to be minus, because it's plus and negative, 0.145 times 25. Or you can say plus, negative, but you're minusing, pardon me, I'm saying this wrong. It is minus, because it's the difference between the two. When you're minusing a negative, you get a positive, and this gives you your impulse. So it's minus the negative. Everyone messes this up because it adds, and that will be your impulse. And then when you're asking the question of the force, once you know this number here, box here, whatever, that equals to F times T, and you can find the average force because you know the time. The time was this number. Note that's in milliseconds, so watch that, and then you can solve for the force.